Hey, what is up everyone? Welcome back to another video, and actually, this video is the beginning of an entire series. We're going to work through the Advanced Client-Side Attacks module on TryHackMe. Now, if you want to get into pen testing, really one of the best places to start with, and I've mentioned this multiple times in my videos, is you need to know web app pen testing. I feel like often we've done a disservice to people because when you want to get into the field, at least for me, when I wanted to get into the field, I focus on network pen testing. I thought I need to know Active Directory. I need to know privilege escalation. I thought I needed to know these things because I was studying for certs like the OSCP. But the truth is, if you want to land your first pen testing job, you don't need to know network pen testing. You don't need to know privilege escalation. Truly, what you need to know is web app pen testing, and you need to know it well. And the reason for that is, as a pen testing firm, the vast majority of the assessments that we do are web apps because most companies have web apps. Web apps are external facing, internet facing, so they want to make sure they're secure and they are more affordable than some of the other assessment types. So when a company is just filling out a pen testing firm for a partnership, it's often beginning with web app pen testing. And as a junior or associate pen tester, you're going to spend the bulk of your time doing web apps and APIs. So you need to know client-side attacks, but it's something we don't often focus on. So I would encourage you, if you want to become a pen tester, lean into this and let's work through this together. Now, I haven't even looked at these rooms. I don't know if they require a TryHackMe subscription or if some of them are free, but if you are able, I would encourage you, don't just watch me work through these rooms. Log into TryHackMe and let's do this alongside of each other. If you're watching this after the fact on YouTube, you can pause the video. You can try it on your own. If you get stuck, play the video, see how I do it, and we'll kind of go through this together. And also, as usual, I'm going through this room and this module completely live. Unlike other content creators, many content creators will go through a room or a challenge machine ahead of time, and they'll just write all their steps on a second monitor, and then they'll solve the machine in 15 minutes, and you're kind of left scratching your head like, how did you know to go from there to there to there? But what I do that's a little bit different is I don't prepare at all. I go into it blind. I share my full thought process, my full methodology, the things that make sense, the things that don't make sense. And as we go through advanced client-side attacks, I'll even tell you, like, here's how I see this happening on real pen tests that I do on a daily basis for my day job. So without any further ado, let me go ahead and share my screen. I want to first just show you how to access what I'm going to be going through. So if you're on the main TryHackMe homepage right here, go ahead and click the Learn tab at the top here. And we will click Learn. And from here, we are going to do Module. So you see all of these here. Click Modules right here. And I think we can actually search for it. Let me just go to search, and I'm just going to do client. Will it pop up? Okay, maybe that's not the best way to do it. There we go. Click Modules, and then we can search, and it's right here, Advanced Client-Side Attacks. So once again, search Modules, type Client, and you will see it pull up. And here is our module. So let's figure out what we are working with today. It says, through real-world scenarios, you will gain a detailed understanding of client-side attacks, including cross-site scripting, cross-site request forgery, DOM-based vectors, SOP, and CORS vulnerabilities. And this module will guide you through the complex landscape of client-side attacks, focusing on vulnerabilities introduced by those things we just talked about. We'll dissect various types from reflected to stored and DOM-based, demonstrating how attackers inject malicious scripts into web pages. We'll then pivot to CSRF vulnerabilities, revealing how attackers trick users into executing unintended actions on a web application in which they're authenticated. As we start into DOM-based attacks, you'll learn about manipulating the DOM to execute malicious scripts, highlighting the importance of client-side security in web pages. Further on, we'll understand the idea of SOP and CORS, essential security mechanisms designed to control how resources on a web page can be requested from another domain. Each section of this module is strengthened with real-world scenarios designed to understand, effectively mitigate, and protect against these client-side vulnerabilities. Looks awesome. And I just want to give a huge shout out to the TryHackMe team. I know I say this often, but I really feel like this year in particular, TryHackMe has stepped their game up. Like, I cannot keep up with the number of releases that come out. I think TryHackMe is releasing 2 to 3 rooms every single week, like 2 walkthrough rooms and a challenge room every single week. Just blows my mind. So hats off. If I had a hat, kudos to TryHackMe. But here we go. It looks like we begin with cross-site scripting, then CSRF, then DOM-based, and CORS, and it looks like a challenge room, I'm guessing. Yeah, it looks like a challenge room, so a CTF on the end. Don't know how long these rooms take, but let's dive in. This first video, we will go through cross-site scripting. Now if you're new to TryHackMe, I did already connect to the VPN. If you haven't done that, you just go to your profile, click access, and there's instructions there to get connected to the VPN. But here I am, I'm on the VPN, and here is my IP. The other thing I'm going to do that's probably a little bit unique is I'm going to try to do this entire room or this entire module using Cato, which I'll showcase Cato a little bit later. Burp Suite is what a lot of people use, and honestly, you'll probably use it in the field. But for bug bounty and just for your own learning for CTFs, I personally prefer Cato because it's much more affordable. It's not rate limited on some of the attacks, but whether you know Cato or Burp, both will transfer over well to a pen testing role as you dive into things professionally, or maybe just a new tool to try out. Cato is a web auditing tool, sort of like Burp Suite or OWASP Zap, but written from the ground up in Rust. I like the way it looks, I like the way it functions, and the developers are super responsive on Discord. Matter of fact, I remember the first time I showcased Cato, one of the lead developers jumped on the stream and took suggestions from me in real time and made updates to Cato as I was just giving random suggestions on my feedback. So ever since they did that, I've been sold on Cato and always want to do what I can to support them. But here we go. The other thing I'll do is I'll read through the room in its entirety. So if you don't like reading through the rooms, you often miss little details when you skim past it. So I'll slow down. I will be your audio reader as we dive into it. Okay, Christopher said, is Cato expensive to learn? No, it's free. You can get a paid version of Cato, which is only $200 for the entire year. I think it's $200. But even the free version of Cato will allow you to do everything I'm going to showcase on this stream. All right, let me zoom in. So cross-site scripting. Let me just pause here. You need to know what cross-site scripting is. Like, make sure you have this memorized. I know this from experience of hearing about pen test candidates being hired. So many people who apply for a pen testing role do not even know how to explain cross-site scripting or how its JavaScript is being used or how it's client-side or how it attacks users. So please lean into this. If you have a pen testing interview coming up, you will be asked about cross-site scripting. I guarantee it. All right, cross-site scripting remains one of the most common vulnerabilities that threaten web applications to this day. Cross-site scripting attacks rely on injecting a malicious script, and keep in mind it's JavaScript because that's going to actually be an interview question. What language is cross-site script executing in? The answer is JavaScript, in a benign website to run on a user's browser. The other thing I'll add about cross-site scripting is this is where I have found multiple CVEs. So I have found cross-site scripting CVEs in Silverpiece as well as in Go CMS. Go CMS is used by major organizations like Mozilla, Apple, and OpenAI. My CVEs on them is by exploiting cross-site scripting in the real world on real applications. I also see this all the time on web tests. I would say probably 90% of the web app pen tests I do, I'm able to get cross-site scripting working in the real world. In other words, it exploits the user's trust in the vulnerable web app, hence the damage. One of the earliest cross-site scripting vulnerabilities was recognized in 1999 and led to Cert Advisory CA 2002. Over the past decade, various robust web security practices have become part of modern web application frameworks, protecting against many cross-site scripting vulnerabilities by default. On the other hand, the motives and sophistication of the attacks have also grown. With the rise of web apps, it is no exaggeration that a few cross-site scripting vulnerabilities are discovered and exploited every month. In the OWASP top 10, which you should also have that memorized if you are trying to get into a pen testing role, these are the top 10 most common attacks on web apps. Make sure you have that memorized, know how to explain each one of those, and a suggested remediation for each one. Cross-site scripting was ranked 7th in 2017. In 2021's report, it was grouped with the other injection attacks and together are ranked 3rd. This room explores cross-site scripting in depth to help you discover, exploit, and patch cross-site scripting vulnerabilities. So a room prereqs. It's expected to have a basic knowledge of HTTP and how websites work. If you don't have this knowledge, we recommend completing How the Web Works module first. I wonder if I ever did this module. Let's check. I did not, but I'm sure it's awesome, so make sure you do that. If you're unfamiliar with cross-site scripting, we highly recommend completing the Intro to Cross-site Scripting room as this room builds on it. Did I do this room at some point in time? I did. Look at that. I did that entire room. It'd be cool if it told me the date when I did it, like date I completed, but I don't know when I completed it, but clearly I did it at some point in time. Finally, this room uses code snippets in PHP server side, JavaScript, client side, Python, and C#. Knowledge of all these programming languages is not required. Instead, we explain the necessary code lines and focus on the causes and remedies of cross-site scripting vulnerabilities. And one question I often get on my live streams and on Discord is, Tyler, do I need to know how to program to be a pen tester? Oops, I hit my keyboard. The answer is no, you do not need to know how to program to be successful as a pen tester. What you do need to know how to do is at least read code and follow the logic in the code and be able to do some minor edits to code, like know enough Python that you can fix a script if it's broken. And honestly, with the advent of ChatGPT, it makes a lot of those things a lot easier because you can understand a little bit with ChatGPT's help. But I would say you don't need to know how to write actual programs, but it is helpful to be able to read code. And if you do know how to actually code, that will help you out a lot, but definitely not a requirement to be a pen tester. Below is a list of the rooms that you can use to fill any knowledge gaps before starting this room. So you can see those here. And learning objectives. Upon the completion of this room, the user should gain a more in-depth understanding of cross-site scripting, in particular, reflected, stored, DOM-based, and how to protect against it. All things that will come in super handy in an actual pen testing interview. We provide code snippets using different frameworks to understand better the exploitation securing against it. We don't focus on the code itself. We focus on the reasoning behind the vulnerability and some solutions. The purpose is to help better understand why cross-site scripting came to exist and what makes it exploitable. Fantastic. I completed that room. Well, you guys saw it on stream. I did complete that room. Let's go. I'm not even lying by doing that. So I'm guessing we're going to have a lot of theory, then we'll get to the hands-on, but the theory stuff is important. All right, as already stated, cross-site scripting is a vuln that allows an attacker to inject malicious scripts into a web page viewed by another user. One thing I also wanted to mention, let me make myself smaller too on the screen. I don't want to cover up the text. My head doesn't need to be that big. There we go. Let me know, guys, if my head gets in the way of anything, and I'll adjust it. But one other thing I want to mention is for bug bounties, cross-site scripting is also super helpful. I have made, just in the past year, I think $800 from bug bounties, specifically cross-site scripting. So once again, really common vuln that you will see in the real world. You can make some money off of it. Consequently, they bypass the same origin policy, or SOP or SOP. This is a security mechanism implemented in modern web browsers to prevent a malicious script on one page from obtaining access to sensitive data on another page. SOP defines origin based on the protocol, host name, and port. Consequently, a malicious ad cannot access data or manipulate the page or its functionality on another origin, such as an online shop or a bank page. Cross-site scripting dodges it as it's executed from the same origin, it's executed on the page. JavaScript for cross-site scripting. I'm telling you guys, drill this into your mind. Cross-site scripting is JavaScript. JavaScript is used for cross-site scripting. You will be asked this question if you're doing a pen test interview. Basic knowledge of JavaScript is pivotal for understanding cross-site scripting exploits and adapting them to your needs. Knowing that it's a client-side attack that takes place in the target's web browser, we should try our attacks in our browser similar to that of the target. It is worth noting that different browsers process certain code snippets differently. In other words, one exploit code might work against Google Chrome, but not against Mozilla Firefox or Safari. Suppose you want to experiment with some JavaScript code in your browser. In that case, you need to open the console found under Web Developer Tools on Firefox, Developer Tools on Google Chrome, and Web Inspector on Safari. Alternately, use the respective shortcut. So I'm in Firefox here. We can do Control-Shift-K, and that will open up the console right here, right? And here is our console. Don't know if we're going to do anything with it, but let's review and try some essential JavaScript functions. So alert, you can use the alert function to display a JavaScript alert in a browser. Try alert, so we can go ahead and do that. So we'll once again open it up, Control-Shift-K to open up our console. And we can do something like, clear, and we'll do alert 1337. And you can see there, look, I have cross-site scripting and try hack me. There's my alert message 1337. Really the better payload to do to show it's coming from the domain. Oh, that didn't work. There we go. So it shows it's being executed on tryhackme.com with document.domain. But let's go ahead and try a few more of these. Console log, similarly, you can display a value in the browser's JavaScript console using console.log. Try the following two examples in the console log. All right, so we'll do console.log1, and you can see one in console.log test. And you can see there it is. Encoding. The JavaScript function Quit freaking out. The JavaScript function BTOA string encodes a string of binary data to create a base64 encoded ASCII string. This is useful to remove white space and special characters or encode other alphabets. The reverse function is a tab base string. All right. Furthermore, you can experiment with displaying values such as document cookie by using alert document cookie, for example. And I did document domain. Document cookie is another way to prove that. Keep scrolling. There's alert hello world, blah, 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 just showing everything that we did. Okay, we can probably close that out now. To recap from the intro to cross-site scripting room, there are three main types of cross-site scripting. We have reflected. This relies on the user control input reflected to the user. So you basically needed them to go to a specific URL. This is often used in like a phishing attack. Stored cross-site scripting, more severe. This attack relies on the user input stored in the website's database. For example, if users can write product reviews that are saved in a database, hence stored, and being displayed to other users, the attacker would try to insert a malicious script in the review so that it gets executed in the browsers of other users. And finally, DOM-based cross-site scripting. This exploits vulnerabilities in the document object model. We'll explain this. I know it sounds confusing, but it'll make sense. To manipulate existing page elements without needing to be reflected or stored on the server. This vulnerability is the least common among the three. So, interview question. You are applying for a pen testing job. And you are going to be asked, what are the three kinds of cross-site scripting? Well, there's your answer: reflected, stored, and DOM-based. So, what cross-site scripting vulnerability relies on saving the malicious script? Let me ask, I want you guys to answer this first. For those of you watching the live stream, without looking above, do you remember what it is? You don't need to say it in chat, but I want you to tell it to yourself. What one is saving? So think saving of stored, right? So stored cross-site scripting. What vuln executes within the browser session without being saved? Well, it's not being saved. So you think about it's in the URL often. So it would be like a phishing attack would be the initial entry point to get someone to click that URL. Well, that's going to be reflected. Hence the name. It's reflected back to the user. And DOM is document object model, right? I always actually forget that. Yeah, document object model. There we go. All right, causes and implications. Cross-site scripting is a web vuln that allows an attacker to inject malicious scripts. I think we already understood that. As a result, the unsuspecting users end up running the unauthorized script in their browser, although the website they're visiting is trusted to be benign. Therefore, it can be a severe threat because it exploits users' trust in a site. Let me show you guys this in the real world. Here is when I found 8 CVEs in this Silverpeas application. This entire blog post that I released, see my name up there, that cool dude, is about the cross-site scripting one. Because what this allowed me to do, and now that you understand cross-site scripting, this might make sense how you see it in the real world. I noticed that I could write a message to the administrators. And if you just did script, it didn't work. I had to do a very simple bypass. But I wrote to the administrator, I captured it with Burp Suite, and I put in this very simple bypass to execute JavaScript that just is going to prompt with the number 9, and I sent this message to the administrator. Well, when the administrator viewed the message, the JavaScript executed. But with that, because I have JavaScript execution in the context of the admin, I can do almost anything the admin can do if I can create the right JavaScript payload. So you can see this. This actually took me some time because I had to bypass a few restrictions, but I was able to create this payload right here, which what this payload is going to do, we need the ID of our user, the last name of our user, and the STKN of our user, which is kind of Silverpeas CSRF token, which we'll talk about sure in this room. But anyways, I was able to formulate this payload that when I sent this payload to the admin user, as soon as the admin user viewed my message I sent them, it automatically made my attacker account the admin. So that's privilege escalation via cross-site scripting. And then with that, there's something in Silverpeas called the Silver Crawler, which is like file read by default. So then with my admin privileges, I had full file read on the server as root. So that's cross-site scripting leading to privilege escalation, resulting in file read on a server. So real web app, real vulnerability, real CVE that I was able to find by exploiting what we're talking about in this Try Hack Me room, cross-site scripting. So what makes it possible? Well, there's many reasons why it's still found in web apps. Below we list a few of them. Insufficient input validation and sanitization. Web applications accept user data, right? You never want to trust that via forms or in Silverpiece via a message, and use this data in the dynamic generation of HTML pages. Consequently, malicious scripts can be embedded as part of the legitimate input and will eventually be executed by the browser unless adequately sanitized. That's exactly what I exploited. Lack of output encoding. The user can use various characters to alter how a web browser processes and displays a web page. For the HTML part, it is critical to properly encode characters like that and that in their respective HTML encoding. For JavaScript, special attention should be given to these. Failing to encode user-supplied data correctly is a leading cause of cross-site scripting vulnerabilities. Improper use of security headers. Various security headers can help mitigate these vulns. For example, content security policy mitigates cross-site scripting risk by defining which sources are trusted for executable scripts. A misconfigured CSCP, such as overly permissive policies or the improper use of unsafe inline or unsafe eval directives, can make it easier for the attacker to execute their cross-site scripting payloads. So just think, defense in depth. It's not one of these will fix it. You should have all these things in place on your web app to prevent this attack from happening. Improper use of security headers. Various security header. Oh, I already read that. Framework and language vulns. Some older web frameworks did not provide security mechanisms against cross-site scripting. Others have unpatched vulns. Modern web frameworks automatically escape cross-site scripting by design and promptly patch any discovered vuln. And third-party libraries. Integrating third-party libraries in web app can introduce cross-site scripting vulnerabilities, even if the core web app is not vulnerable. All right, lots of reading. Drink a cookie. A drink of cookie. What? Drink of water. I saw Cookie down there. All right, how's stream doing? Everything going good? Yeah, looks like it is. All right, let's keep going. Implications. All right, session hijacking. We can steal session cookies if the session cookies aren't configured properly. Take over the session, impersonate the victim. Phishing and credential theft. You can do a fake login prompt. In one recent case, the browser page was partially hidden by a dialog box, social engineering, legitimate looking pop-up or alert, blah, blah, content manipulation, defacement. So yeah, you can actually use cross-site scripting to deface websites, which is interesting because with the JavaScript, you can, as soon as a user sees the JavaScript, it will modify the website. Data exfiltration, you can access and extract any information displayed in the user browser, malware installation, and the only thing I would add is just like, you can just get the user to do stuff, right? For example, for me, I was able to get the admin to make me an admin. A writer said, I saw cross-site scripting. My first chunk of code I sold was cross-site scripting as a Steam group invite worm, $5 in 2009. Amazing. Amazing, dude. And actually, guys, did you see the cross-site scripting vulnerability in Counter-Strike recently? This kind of took the internet by storm, and people were confused about this. Let me see if I can find a good article about this. I play Counter-Strike 2. I wish I would have discovered this. People thought like, oh my goodness, I'm being hacked. You weren't being hacked. It was client side, but what you were able to do was get players' IP addresses. And I believe it was setting your name, right? And then when you voted, it would do it. Let me see if I remember right. By utilizing the image tag, which is actually what I did in Silverpiece, malicious actors could trigger a remote IP logger script logging the IP of every player exposed to the vote kick. Oh, so you set it, you vote kick, and then you're able to get that information and grab people's IP. So there's YouTube videos on that. When I first saw it come out, I so badly wanted to go in there and do it myself and make a video about it. But that's very much a gray area. Because I saw it when it was still active. Like I could have gone into Counter-Strike and exploited it, even if I made my own server and did it. That's very much a gray area because if I'm not running it locally, so for example, when I talk about CVE hunting, I always tell people spin up the application locally. You don't do CVE hunting on real people's websites, and you don't execute cross-site scripting on a Counter-Strike 2 that you can't run locally. Like it is on their servers. You are technically hacking their servers in some, I mean, very minor way, but technically doing it. So I thought I probably shouldn't make a YouTube video of me of like actually breaking the law and exploiting this vuln, but it seemed to be super easy to exploit. Oh man, Get Glock said Steam has a command injection vuln that is going right now where you can add unlisted items to your cart if you know the ID. Sounds kind of like IDOR type stuff. But let's dive into this. I just found that interesting. Oh, that's actually a good call. A writer said host a server as a VM, then use hardware pass-through to a VM for a guest VM. All right, based on the leading causes of cross-site scripting vulnerabilities, what operation should be performed on user input? Well, there's a few different things, but I'm guessing what we're looking for here is input validation and sanitization. I am just going to copy and paste that because I will spell it wrong. Oh. There we go. To prevent cross-site scripting vulnerabilities, what operation should be performed on data before it is outputted to the user? Well, that's going to be encoding, I would think, right? Let's see if I'm right. All right, we're almost to a vulnerable web app. Let me go ahead and start this machine so we don't have to wait for it to start. So when we get to it, it's ready to go. But reflected cross-site scripting. Reflected cross-site scripting is a type of vulnerability, and probably the most common and in some ways least severe, where a malicious script is reflected to the user's browser, often via a crafted URL or form submission. Consider a search query containing script document.cookie. Many users wouldn't be surprised about such a URL, even if they look at it up close. If processed by a vulnerable web app, it will be executed within the context of the user's browser. In this innocuous example, it displays a cookie in an alert box. Obviously, an attacker wants to achieve more than just displaying the cookie as an alert to the user. However, for such an attack to be possible, we need a vulnerable application. One simple reflected cross-site scripting vulnerability is when the user searches for some term and the search string is included verbatim in the results page. This simple scenario provides an easy target for the attacker to exploit, and I see very similar things often in the real world. Although discovering such vulns is not always easy, fixing them is straightforward. User input such as that should be sanitized or HTML encoded to that. In the following subsections, we provide examples of vulnerable code in the following languages and frameworks. We got PHP, JavaScript, Node.js, Flask for Python, and C#. All right, let me look over at chat. Lots of things going on in chat. A writer said anything not text should be converted to ASCII and cross-referenced to clean. Yeah, good call. Oh, wow, interesting. A writer said ages ago I was working on something like cross-site scripting on Facebook using notes to store a payload and JavaScript to pull in and val on the victim. Very interesting. A question, how did I learn how to solve or resist the 3 cross-site scriptings? Solve or resist? What do you mean? Like patch them? Part of it, like here's the other interesting one that I'll show you guys. Here was another CVE I discovered and disclosed. This was in Go CMS, but what was unique about this one is I not only found it, but I patched it myself. And you can see they approved it. So now it's actually in the official Go CMS thing. So this is a lot harder for me to patch this than it was to find. This was actually an SVG file, so I was able to upload like a profile picture as an SVG, and when the admin went to my profile picture, it executed JavaScript, and I was able to elevate my privileges from contributor to owner, I think, if my memory serves me correct. And the way I sanitized this was with, I'm blanking on it now. It's a library for sanitizing SVGs. I think I talked about how I patched it. Blah, blah. So I used DOM Purify. Yeah, so I used DOM Purify to purify, and I even include an example here. So here would be a malicious SVG, and the reason it's malicious is you can see my script right here. Obviously, it's not doing anything malicious itself. It's just executing document.domain to show the JavaScript to be executing the domain. But after running it through DOM Purify, it kept the image format still, so it still has the height and color, but it removed all of the scripting. So that's how I patched it in Go CMS, was with DOM Purify. So it's unique based on the example, but I will say, like, kudos to devs. People often exploit CVEs and they're like, why don't they patch it for me? Well, you patch it yourself. The beauty of a CVE is it's open source. So if you can find the vulnerability, go the extra step and patch the vulnerability. And that's a cool story to tell. I found a cross-site scripting, I found a CVE and I patched the CVE and the maintainers approved it. That's a pretty cool story to be able to tell, and you're actually helping out the maintainers yourself. You're saving them a lot of work on their end. Oh, how did I learn how to sanitize this? Things like Try Hack Me, dude. Try Hack Me and Hack the Box is how I learned all this. How often do I see WAFs when pen testing? I mean, pretty often, but generally when you do a pen test, like a web app pen test, a client will actually turn off the WAF in order to give you full access, because like WAFs are not, it's defense in depth, right? But with enough time, an attacker can bypass your WAF, your web application firewall. So for a pen test, because they're paying us for a time-limited engagement, they'll often turn off the web application firewall so we don't have to deal with it. HackThisSite.org, you play with the realistic? Yeah, so HackThisSite.org is when I first got started. I was 14 years old in high school when I started playing with HackThisSite.org. I think I did the realistic stuff, but honestly, I don't remember. It was so long ago. I should have a stream where I go back to HackThisSite.org for fun. But yeah, dude, I remember I was like 14, 15 years old. I'd pull all-nighters on HackThisSite.org and go through their challenges. That's first where I learned stuff. So cool. Before the Try Hack Me's and the Hack the Boxes of the world, there was Hack This Site. All right, let's look at our vulnerable code. So look at the following code snippet in PHP and figure out why it might be vulnerable. I want you guys to look at this before I tell you the answer. Anyone see why this might be vulnerable? Answer it in your head. And the answer is this. When I look at this, right, we have a search query that's taking user input directly from the search query, and it's passing the user input directly into this query without encoding or escaping it. So right here, we could put a script here, and it would execute it as JavaScript because it's not encoding and it's not sanitizing this user input at all right here when it's reflected back out to the user. All right, if you are unfamiliar with PHP, get is PHP array container values from the URL query string. Furthermore, get Q refers to the query string parameter Q. For example, in this line right here, so Q right there, table has a value table, and that's user controlled. As you might have guessed, the vuln is caused by the search value displayed on the result page without sanitization. Therefore, an attacker can add a malicious script to the URL knowing it would be executed. For example, as a proof of concept, the following URL can be tested. Document.cookie, and if the site is vulnerable, an alert box will appear displaying the user's cookie. Luckily, fixing this code is simple. So you can see this. We have our search queries still. We're still taking that input, but we are sanitizing it here, and then it's only doing the escape sanitization. So you're just making it so you can't execute the HTML special characters, the cross caret key things. I don't know what they're called. The PHP function that converts special characters to HTML entities. Those characters are replaced by defaults to prevent scripts in the input from executing. You can read its documentation here. All right, JavaScript, Node.js. The following Node.js code snippet is vulnerable to reflected cross-site scripting. Try to find the vulnerable part and think of a solution. All right, so we have our search term right here. I mean, simple to what it was before. We have our query queue right here, and it's defining a search term based on our query, and it's just echoing that search term out right now without sanitizing, escaping, or anything like that, and it's going to fail. So very similar to the one we just saw. You can see it's still going to get executed the same way. In our fixed code, we are sanitizing it with sanitized HTML in Node.js, and it's going to do something similar to what HTML special character does up there in PHP. Blah, blah. Another approach would be using escape HTML instead of sanitize. As name indicates, escape aims to escape the characters, etc., etc. All right, Python Flask, vulnerable code. Consider the following simple Flask application. Try to find the vulnerable part. So we have here our route search, and we have something easy again here. We have a query variable, and the query variable is defined by the argument being passed to it, which is the Q. So we're going to pass it a query argument, and it's going to echo it out what the user put in with no sanitization, no escaping. And you can, of course, see it's going to do the same thing as the other vulnerabilities. And here is our fixed code. It's going to escape the query. So another Python function that's going to do something similar to what we already saw above. All right, so HTML escape is actually an alias for markup safe escape. They both come from the workzerg library and serve the same purpose, escaping unsafe characters and strings, blah, blah. ASP.NET, vulnerable code. All right, I think you guys are kind of getting this at this point. We have right here our vulnerable code, and it's echoing out with certain variable user input, and it's echoing out with no sanitization or escaping. And the fix code. So once again, fixing it is very similar in all of these, just different libraries, different ways of doing it, but still look similar. You see our encoded input. We're using this in ASP.NET or C#, and that's going to fix it for us. Okay. Let me look at chat. That was a lot. Oh, a rider is gifting 1 sub to the community. Amazing, a rider. Seriously, thank you so much for your generosity. Really do appreciate it. A rider said we need a sanitize function, pass the var into that, and reset the variable on the initial. You got it. Crash that script is one of the easiest to encounter, assuming you know how to sanitize. It is, yeah. And like what TryHackMe was saying is not many, like all of the modern web frameworks do this for you if you just implement it properly. Like this Gizmo said, I actually made a website in Flask when I was into software dev that you got cross-site scripting and server-side template injection on later on. That's amazing, dude. The server-side template injection is really cool. That's a server-side attack, and I think TryHackMe also has an advanced server-side attack module I want to do. But with server-side template injection, you can actually get full RCE and a full shell with that, which is cool. Server-side attacks are fun. Ryder said, bro, you teach, and I'd rather gift yourself for others to stick around and learn. Yeah, thank you so much, dude. Seriously, you're awesome. All right, let me look over at YouTube. Christopher said, Young said, is enumeration just a fancy word for looking around? Yeah, basically. Q is a parameter, yep. Chris said, this feels overwhelming. How do we learn all these nuances and all these language variations? A lot of it is muscle memory, right? It's digging into these things and just doing it all the time. This is why I'm on stream all the time, guys. When I was trying to get into pen testing, I did like a CTF machine every single day and documented it and learned through the process. The only way to learn this stuff, guys, is you have to keep doing it. You cannot give up, and it doesn't make sense right away. But as you go through this every single day, pieces begin to fit together. You begin to see these patterns. Oh my goodness, another one. A rider's killing it, man. You're the real MVP. Thank you, dude. Seriously. You're awesome. I appreciate it. Kevin said, well, this is a great question. So Kevin over on YouTube said, what would be the main difference with SQL injection? The code flaw seems very similar. Yeah, it actually is very similar. The difference is with SQL injection, you have to remember it has to be processed by a SQL database on the back end. So for example, if our code, we could take any of these codes, right? So if we take, what's our first code up here? If we take this code right here, and let's say this is a login, and it was like a post request, and it was sending, let's say, username, and it was checking a backend database if the username exists, but it doesn't escape anything on the SQL, then you can do SQL injection. So the attack is similar in that both rely on unsanitized user input. The difference is SQL injection is server-side. You're attacking a back-end server, and you're interacting with that server, right? So there's a backend server you're interacting with here. There's no backend server we're interacting with, so there's no way we could do SQL injection. Hopefully that's helpful. Yeah, the real Bilbo, spot on. So the real Bilbo said over on YouTube, taking notes helps a lot. Yes, taking notes helps a bunch as you go through some of this stuff. All right, let's keep going. Oh, which one of the following characters do you expect to be encoded? Anyone know? I think that which one of the following characters do you expect to be encoded? Well, let you guys think about this. You don't have to say it in chat, but if you know HTML, even basic HTML, you should know this one. Right? We're looking at the sideways caret key thing. Because like in HTML, so if like the first thing you learn in HTML, right? Like if I want to make a header, remember you do H1, please subscribe, right? And then you close out, you close out your header with those keys. And like if we want to do a paragraph, right, very basic stuff, this is a paragraph. This is how you do it in HTML, right? So If the user can't do that, they're not going to be able to execute HTML. Same with the script, right? So a script, you're looking like that. Script alert document.domain, and then you have your script right there. All right, what function can we use in JavaScript to replace unsafe special characters as HTML entities? Well, if we go up to our JavaScript node.js right here, you can see that we can use sanitize HTML. And maybe we don't need that. Oh. Did I read that wrong? What function can we use in JavaScript? Do. Oh, escape HTML. My bad. I'm thinking sanitizing. It's asking about escaping. I did read it wrong. There we go. And I bet it wants these on the end. All right. What function do we use in PHP to replace HTML special characters? Well, if we go up to our PHP, we used HTML special characters. And this isn't stuff you would need to memorize for like a pen testing job interview. You wouldn't need to know, like, hey, they're not going to ask you what function do we use in JavaScript to replace special characters. They are going to ask you, how do you remediate cross-site scripting? Well, you can say you remediate it by sanitizing and encoding special characters. Sanitizing user input, encoding special characters. That is how you remediate it. All right, fantastic. Here is our vulnerable web app. The attached VM runs a vulnerable version of Copy Party. They discover reflected cross-site scripting has an ID. So like y'all could have discovered this, right? This is how you do some CVE hunting. A writer over on, wait, a writer, are you on both things? Can you remind why cross-site scripting is important today when thinking about SSL and how it prevents man-in-the-middle attack? I'm not sure if I fully understand your question about how SSL prevents man-in-the-middle attack. And with cross-site scripting, you can even like keylog and stuff. Both, baby. You tell me, man. I'm not entirely sure what you are asking there or what you're looking for. I know you know the answer. You're based on your comments. You've been doing this longer than I have. Harshit said, "What are we doing today? We are doing the advanced client-side attacks." A writer said, cross-site scripting bypasses SSL by being wrapped within the trusted SSL. Oh, gotcha. Yeah, that makes sense. A writer, if you don't mind me asking, how long have you been in the world of hacking, pen testing, cybersecurity? All right, the exploit code is this. I love this, right? URL encoded, which is a URL encoding of this. The attached VM has a vulnerable server running on port 3923. You can reach a vulnerable server in here via your attack box's browser. Well, let me just show you guys Cato as I pull this up. So here's Cato. Cato is sort of like Burp Suite, but way more affordable for those who don't have Burp Suite Pro, and you're not rate limited on a bunch of stuff. So I'm going to create a project, and we will call this project THM cross-site scripting, and we'll do create. And we'll go over to Intercept. Let me open up the browser here. There we go. And we will copy this. Go to our tab here and see if it opens. And it does. So there we go. We have it open there. And the attached VM has that. And here's the payload that we can put in there. So let's just give it a shot and see if it works. And there we go. It does work. It executes the JavaScript for us. We could change this to like, this is how a real hacker does PLC for cross-site scripting is 1337. So what type of vulnerability is that? So pay attention real quick. it's not stored on the page, right? It's actually in the URL. So to exploit someone with this, you need to do phishing or social engineering, because you need to get them to go to this URL in their browser, right? So it's reflected. It's not stored on the site. It's reflected based on when the user looks at it. Kind of like a mirror, right? It's a reflected cross-site scripting. So reflected cross-site scripting. Use the above exploit against the attached VM. What do you see on the second line after go to? Is that what it's looking for? All right. So very simple example, but you see it all the time. We could even show this to you. If we look at reflected HackerOne, we could look at some HackerOne reports and how people have found this in the real world. Let's just look at a couple of these to see it in the real world. Oh, we got Go Pro Slow Yo. What's up, Go Pro Slow Yo? Thank you for joining over on Twitch. And then a writer said, I was paying for crypts back in 2008 and learning how to tear apart and re-implement custom crypts back in 2008. That's amazing, dude. Wow. Cross-site scripting in Load.js and rebuild the page to what you want. Pull the Facebook login page to a variable and dump it to the output. Crazy. All right, let's check out some of these findings. Oh, they found it on HackerOne? What? So let's understand what they're doing. They have this mini title stuff, and then we have a mini URL here, and then they're executing the JavaScript there. It's intermittent. Nice. Look at that. He got a total of a $500 bounty from what I can see. $450 and then $50. Oh, two people. So look at that. That's about what I made when I found the cross-site scripting in Bug Bounty. Here's a Starbucks one on the return URL. Commonplace that you see it is on return URLs like there. You can see the JavaScript. They encoded it. They separated it to encode it because it was probably looking for JavaScript, the word, and escaping it. So they did that weird encoding stuff to bypass the restriction there. You have their screenshot right there. It looks like they're echoing document.domain, which I said is a good POC because when you do document.domain, it proves that it's executing on starbucks.com. Let's see what they got. Oh, it didn't tell us the bounty report. Let's look at one more. In PUBG.com has an endpoint that is vulnerable, which is, oh, they're throwing in this PUBG. So very similar to what we saw before. Remember, we were looking at a /Q parameter. This is a /P parameter, but very similar to what TryHackMe was talking about. And then they have it there. It looks like they're doing document cookie. They send a video. All right, and then they have the disclosure. So once again, just showing you guys real world stuff that you see here. Drink of water and we'll keep going. You ever touch on using HT access and PHP file server JPEG as PHP so the client thinks it's PHP but it's JPEG on the back end? I think I may have done that in a CTF on stream before, but I couldn't tell you what room. But yeah, with file upload attacks. All right, stored cross-site scripting. This is the one I see most often. Stored cross-site scripting and persistent is a web app security vuln that occurs when the application stores user-supplied input and later embeds it in web pages served to other users without proper sanitizing or escaping. So if you think about the one that I found in Silverpiece, that was stored because it was stored in the message I sent to the admin user. Same with the cross-site scripting I found in GoCMS. It was in an SVG profile picture stored on the page. You didn't have to go to a URL. You just had to view my image and would execute JavaScript. Examples include web forum posts, product reviews, comments, and other data stores. In other words, stored cross-site scripting takes place when user input is saved in a data store and later included in the web pages served to other users without adequate escaping. Stored begins with an attacker injecting a malicious script in an input field of a vulnerable web app. The vulnerability might lie in how the web application processes the data in the comment box, forum post, or profile information section. When other users access the stored content, the injected malicious script executes within their browser. The script can perform a wide range of actions, from stealing session cookies to performing actions on behalf of the user. Yep. So vulnerable web apps. Oh, do I have to launch one? Hold up. Let's scroll down real quick. Wait. Oh, the page disappeared. Let me launch this other machine so we don't have to wait for it to launch. Oh, okay. We'll terminate this one and start this one, and then we'll read. All right, vulnerable web app. There are many reasons for a web app to be vulnerable to stored cross-site scripting. Some of the best practices to prevent it are validate and sanitize input. We kind of talked about that. Use output escaping. Talked about that. Apply context-specific encoding. For instance, within a JavaScript context, we must use JavaScript encoding wherever we insert data. On the other hand, data placed in URLs must use relevant URL encoding techniques like percent encoding. The purpose is to ensure the URLs remain valid while preventing script injection, and practice defense in depth. I think I mentioned this earlier. There's not one way to fix all. Do all of it. Don't rely on a single layer of defense. Use server-side validation instead of solely relying on client-side validation. Oh yeah, Ryder, if you're not part of the HackSmarter Discord, come join it. I will just say, for those of you watching streamer after the fact on YouTube, if you have not joined the HackSmarter community, join it. You can get all the information at hacksmarter.org. So you can see this. You can click there to go to Discord or YouTube, Twitch, even have our community resources here. So if any of you have a blog or a write-up, the only requirement is it's semi-active, so at least once a month. Tag me on Discord. I'll add you to the community resources. But here are some community members who make good walkthroughs or videos on things. But that is HackSmarter. That is our community. We also host weekly goal meetings. We do free career coaching with different pen testers in the field. We just volunteer our time to help people get into the field. Nothing in HackSmarter is behind a paywall. I freaking hate paywalls. I hate influencers who say, hey, pay me $400 and meet with you for a one-on-one session. No, screw that. We'll meet with you completely for free to help you break into the field. Don't pay those dumb influencers who make silly clickbait videos to steal your money. Boom. All right. Vulnerable code. The code below has multiple vulns. It does two things. It reads a comment from the user and saves it in the comment variable, adds a comment to the column comment in a database, and later iterates over all the rows. So let's walk through this slowly. We have a comment variable. It accepts a post request from a user, right? So this would be like, I type in a comment box, hello, and hit enter, or I hit accept or whatever. It's sending a post request to the server. Oh, and we have a SQL query going on right here. We actually talked about this a little bit, right? I think, was that Kevin over in YouTube asked about this? You were right. That is a very similar vulnerability. And here we have inserting into comments comment value. So we're not encoding or escaping this at all. So this would be vulnerable, I believe, to SQL injection with our comment here. And then displaying the user comment result. So we have a result variable that's taking a SQL connection. Select comment from comments, and that's how it's pulling out the comment. So that's going to be both cross-site scripting and SQL. We are concerned with stored cross-site scripting as SQL injections outside the scope. The main issue is that the comment is saved in layer displayed among the other comments without sanitization. So fixed code storing the user comment, and they're escaping as well here to prevent the SQL injection, and then displaying the user comment. Before displaying every comment on the screen, we pass it to the HTML special characters function, which we talked about, to ensure all special characters are converted to HTML entities. Consequently, any attempts for stored cross-site scripting won't make it to the end user's browser. This is outside the scope of this room. However, if you're curious about the SQL injection vuln, this is alleviated using the MySQL real escape string, which I saw, and I actually think there was an Advent of Cyber, I don't think it was this year, not this year, but last year. One of the Advent of Cyber challenges was actually not exploiting SQL injection, but you actually had a patch SQL injection on a server, which is cool, kind of blue team code analysis and patching it. So I don't remember what it is off the top of my head, but I believe it was the Advent of Cyber, not this year, but the previous year, we actually had to do some code patching, specifically doing something like this and patching, identifying and then patching a SQL injection vulnerability. All right, this function escapes special characters in the input string so it can be safely used in a SQL statement. JavaScript. The following JavaScript code reads a comment received from a user that was saved in a database file. We assume the comments array has been populated from the database. Discover what makes it vulnerable to stored cross-site scripting and how to solve it. Well, we have our app get comments, and you can see our comment right here for const comment of comments. HTML, it's adding it to our HTML variable right there with the comment, and it's not escaping or doing anything there, so we just need to sanitize the user input as we pull it out. The main issue is that it reads the user's input saved in comment. Yep, and it's displayed as part of the HTML code. Consequently, when another user views a comment, the browser executes the scripts injected into it, and you can see our sanitized comment, sanitized HTML function on the comment. Part of the solution is sanitizing the HTML before displaying it to the user. We can remove HTML elements outside the allow list using sanitized HTML. In general, we expect to allow basic text formatting such as bold and italic, but we would remove potentially dangerous or unsafe elements such as script and onload. More information can be found on its official page. Python Flask. Similar to the code snippets we have displayed, the following code uses the Flask framework. By now, you can expect the mistakes plaguing this code. And we can go through this. Our SQLite database. We have our comment right here in the database, and we have this post request for a comment. Our content comes from a request form, user input, and you can see it's just automatically adding it without sanitizing it. The first issue is that comment content is set to the user's form submission, which we saw right there. A retrieve from request form content without sanitization. This in itself lays the ground for stored cross-site scripting and SQL injection. Furthermore, when the user wants to view the comments, they're displayed without escaping. Another perfect recipe for stored cross-site scripting. Fixed code. We are concerned with fixing stored cross-site scripting. We need to ensure no malicious scripts are saved in the database. Furthermore, we'll escape any content before displaying it as HTML. So we've already seen this multiple times. We use the escape function to ensure any special characters, blah, blah. As you expect, these characters are converted to HTML entities. We made 2 changes. Although the user submitted input is saved verbatim, the content of each comment goes to the escape function. Okay, got it. Whoops. Right here is what it's talking about. Before it is sent to the user's browser. I'll look over at chat in a second. Y'all know I'm missing stuff in chat. C#, the following C# code is a multiple vuln. Take a quick look at the code and think about what needs to be changed. All right, so we have a variable called command, and we have a new SQL command, insert in a comments value. Of course, we have our user comment right here. It's going to execute the command, and then we have our reader, select comment from comments, execute reader. And it's going to read it. So the issue is it's not encoding or escaping when it's added, and also not encoding or escaping when it prints it. So one of the vulns we observe, the system stores it over comment and then later displays it to other users. Another vuln outside is SQL injection. And then here's our fixed code. So how did they fix it? Well, you can see they use parameterized queries for that. And then our display comments, they did the sanitized comment, HTML encode on the comment when it printed out to a user. All right, if you're curious, SQL injection is fixed by using parameterized queries, which is what I said. This can be achieved by using parameters add with value method in the SQL commands object. What is the name of the JavaScript function we use to sanitize the user input before saving it? I should just memorize that by now. Right. Or we're looking at Node.js, so that would actually be sanitize HTML, rather. Was it JavaScript or was it PHP? What did it ask me? JavaScript function. What method do we call in C# to sanitize user input? Right, that one, I believe. All right, beautiful. All right, let me check out chat. What am I missing? Let me go to YouTube first. Oh, wow, there's a lot of comments. I'm scrolling up, y'all. That's why I'm here. Don't let them dumb influencers steal your money. Yeah, Don't let them. I made a whole rap song about them. Real Bilbo said, I hacked my first box back in the Slackware days. Amazing. Switch to support because back in my day, hacking was always a bad thing. Gone are the days of the Etsy password and Slackware. Last year there was no sequel in one of the cyber side quests too. I don't think I even did the cyber side quest. I did a few of the official videos for the Advent of Cyber, and then I streamed every single day in December. I did every single challenge live in real time, and I didn't feel like also doing the side quests. That was enough streaming for me. Yes, Flask is a Python web framework. You got it. Nunez said, evening, Tyler. Love your videos. New to pen testing, and your videos really break things down. It's taught me a lot. Thanks for what you do. Hey, thank you, Nunez, for being here and for the kind words. And shout out to a rider for doing some awesome teaching over in the comments. Appreciate it. All right. Looking over at Twitch. 101. How do I donate to get a one-on-one with you to go over web apps like I am a 5-year-old? So hacksmarter.org. Join our Discord. There's a whole channel on Discord called Career Coaching. We don't check if you actually donate. We just ask you to donate to a nonprofit of your choice, whatever you can afford. It could be $1, could be $100. And then we have all of our calendars on that page where you can schedule one-on-one sessions. I am currently unavailable for the summer. And the reason for that is, I stay up later now with my kids in the summer. So before I was doing coaching because I put my kids to bed because they went to bed early for school. But now since it's summer, most nights I'm staying up later with them, and then didn't want to try to juggle coaching on top of that. So I took the summer off from coaching so I could hang out with my kids more, but I'll be back to the coaching stuff in the school year. But there's a bunch of other awesome people in the coaching area that will do that. We have multiple pen testers. We have like Ian Austin. Ian Austin was the director of content for Hack the Box and is now the founder of Pwn Labs, where he has an entire platform that teaches cloud pen testing, does it for free. We have other pen testers on there. A writer said, bruh, there a way to toss myself in the pool for coaching? Yeah, send me a DM over on Discord and we'll talk about it. Basically, the only thing I'll need from you is like a very brief bio of what you specialize in, so people know how to reach out to you, depending on what they're looking for. A calendar invite. So I think I use Gmail's calendar thing. Some type of calendar invite so people can look at your calendar and schedule with you. And that's all. I'll get you added to the list. And so, yeah, no spec, I do it all. Yeah, just DM me the information, or just DM me and I'll tell you what we need from you. But yeah, it'd be an honor to have you join that coaching team. All right, let's keep on going. We have our vulnerable web app 2. Start the attached VM, which I did. The attached VM runs the vulnerable project hospital management system. The project was uploaded a few years ago and was never updated since then. It is fully functional. Unfortunately, the historic cross-scripting vulnerability was discovered and tagged as CVE 2021, and an exploit was published. But the application has not been patched till the time of writing. Let's check out this hospital management system. Did anyone actually use this? So yeah, it has not been updated. So it's like for hospitals to set up appointments with the doctors. Actually, looks pretty nice. I wonder why it was never updated or maintained after that. Bug found. Appointment not work. We have some pull requests that people have done. Security code fixes. So you could probably, if you went over to this this branch over here, you could probably still use it securely, I would guess. Interesting. To exploit the vulnerability, the attacker only needs to click on contact and fill in the name, email, phone number, and submit the payload in the message field. Something simple such as that would still work. Any message, so this is kind of like what I found in Silverpeas via a messaging feature. Any message sent via the contact page appears to the receptionist when they log in. To log in as a receptionist via the corresponding tab, use the following credentials. The attached VM has a vulnerable server running on port 80. You can access it there. And so the vulnerability lies on the contact PHP page. Although the code works well, it is not secure. As we can see in the listing below, the user submitted messages saved unsanitized in the database table. user's message right there. Insert into contact, blah, blah, values that message. All right, so we'll answer this, and then we'll go do this. Go to the contact, submit that, log in as a receptionist. What is the name of the key from the displayed key value pair? So let's go ahead and just check out this app ourselves. We'll probably find other 0 days in it, honestly. So here we go. We can register as a patient. We have a doctor. We can log in as a doctor, and we can also log in as a receptionist. We have an About Us page. There we go. Global hospitals provide the best quality care. Amazing. If we go to contact, here is where it's vulnerable. And let's see if it would be easy for us to detect this ourselves. So what is my name? My name is Tyler. And my email is Tyler at... This isn't actually a real email, so don't try to email it. Well, I don't remember. Maybe this is a real email. I maybe have it. I don't know. But don't email it if you want a response back from me. Oh, I can't do that. Okay. And we'll say, hello, am a elite hacker. And let's turn on intercept here. And we'll just see what this request looks like. All right, so we can see this. We have our text name, our text email, our text phone, our button submit, and our text message. And this is the part that's going to be vulnerable to it. And we can kind of see it here. One thing I always do, and I can even show this here, before I even try to do cross-site scripting, I try to just do HTML injection, which is actually a vulnerability in and of itself. It's a low vulnerability, but still being able to do HTML injection is something. So the way I do this, I would just do like H1, HTML, and we'll see if it pops up as HTML. I will go ahead and forward this request. We get message sent successfully. I can turn that off, and then let's log in as the doctor or whatever. Who am I logging in as? The receptionist, admin and admin123. Oops, admin. Okay, I can't tab. And was it appointment details maybe? No, queries. Oh, see, look at that. So this is actually something, even if we couldn't execute the JavaScript, this would be something worth reporting on a pen test, that we have HTML injection here. Usually when you have HTML injection, you can often get cross-site scripting, but not every time. I've had a few times on a web app where I can get HTML injection, but I can't get cross-site scripting. So this is something I always do in a real web app. I try to do that before I even try to do cross-site scripting. But let's go back over to let's go back to contact, and we do Tyler. Jeez. There we go. And now we can do script, document, whoops. What was I supposed to do? Is it supposed to get the cookie or the document domain? What does it want me to do? Document.cookie. Okay, got it. And we'll send message. Message sent successfully. Go back to home. We will log in as our receptionist with admin 1234. I think. A freaking guy. I can't even. I'm such a bad hacker. I can't even log in when I'm told the password. Was it admin123? There we go. Queries. Oh, did it encode it? Why did it not execute? What dumb thing did I do? Oh, I didn't do alert. Gosh, I'm dumb. You kind of need the alert for the document cookie to actually, pop up. Let's do that again. Telling you guys, I don't know if you guys have ever streamed, but it's like when I know people are watching my screen, I forget the silliest of things. Same with like even at work, like when I share my screen, I miss dumb things all the time. It's just something about your mind goes blank when you know people are watching you. Let's give that a shot. I'm sure I did something wrong there too, but it's kind of hard to mess that up. It literally tells you what to do, and I still did it wrong. Like, that's impressive. There we go. What was the question I was supposed to answer? Go to the contact, blah, blah, next log in. What is the name of the key from the displayed key value pair? Does it mean PHP session ID? Then we can log in as the user. There we go. Boom. All right, we're almost through this. Let me look over at chat. Or a rider said, I'm sitting in lounge if anyone has questions. Yeah, so if you guys have questions, want to go deeper, jump over to the Discord lounge. They gave me the user and passed in the description. That is awesome. So yeah, if you guys want any more deeper help, A Rider M is over in the HackSmarter Discord over in the lounge. Jump in there and chat with him. He'll be able to help you out. All right, let's keep going. DOM-based cross-site scripting. We're almost done with this first module in this path. If you check any updated security advisories, it's easy to find new reflected and stored cross-site scripting vulnerabilities discovered monthly. However, the same is not true for DOM-based cross-site scripting, which is getting scarce nowadays. And what I want to do, before we move on, let's look at in HackerOne. And guys, the way I do these rooms is also the way I do it when I'm offline, when I'm not streaming. When you go through a room on Try Hack Me or Hack the Box, our temptation is just to rush through it to get it done as soon as we can, but that doesn't help you learn, right? So slow down. When you read about a vulnerability, take the time first to take notes on it if you're not taking notes, and also look at it in HackerOne. HackerOne is one of my favorite places to look because you can see real vulnerabilities. Like when I'm learning about cross-site scripting, I always do this. I'm like, how did people find it in HackerOne? How did they find it in real web apps? And what can I learn from that? So stored cross-site scripting will be submitted on reports, and anyone will check the report the cross-site scripting will trigger, blah, blah. So here is the vulnerability. There's that. Create a new network report. Enter this payload. So we're kind of doing some escaping type stuff. Click run, and then the cross-site scripting will trigger. And they got a bounty. It doesn't say the bounty, I don't think, but and they found it on Twitter. Also known as X, which is the freaking dumbest name. That's this. Oh, an HTML editor. So I've tried this on Try Hack Me. When you go through the room creation process and Try Hack Me, there's an HTML editor. And I tried a bunch of payloads to try to get cross-site scripting to work. It didn't work, but these people got to work on whatever this HTML editor is. Did they get a bounty for it? Yep. They confirmed it. Oh, there's a few duplicate records. $700 for cross-site scripting on Twitter seems really weak. Yeah, bug bounties are weird. Like, my best bug bounty, in my opinion, should have been like a $10,000 or $20,000 bug. Without sharing the website, it was a website that has, geez, when I exploited this, it would have been, I don't know, over 1 million users, like actively using this website. So a major website. And what I was able to do, guys, is I found an API that wasn't secure. And via this API, I was able to dump I could take over any user's account. So I could dump this data on users. I'm trying to go off memory. I could dump their username, their email, their password hash, their password reset token, and their MFA reset token. So if you put the attack together, what I was able to do is I could target any user, including admins. I could go to reset their password. And when I would reset their password, I could run the API. I could grab their password reset token. I could go through the password reset process, and I could reset their MFA, change the MFA to my phone, completely lock them out of their account, take over their MFA, take over their account, and it affected every user on this website. And they only gave me $2,000, which $2,000 isn't, you know, minor money, but in my opinion, like, y'all, I could have destroyed you. Like, I could have dumped all of your data of all those users, and they, I believe they would have been facing fines like in the GDPR type stuff. Like, by me reporting this to them, I saved them thousands upon thousands of dollars, and they just gave me $2,000. Like, bruh, give me more than that. For real. I took my $2,000 though and got over it. You interested in popping in chat for a minute? I'm not going to jump in chat right now, but only because I'm recording this video after the fact for YouTube as well. So I want to make sure I keep this piece standalone for YouTube. All right, let's continue through this room, see if we can finish it up. DOM-based cross-site scripting. If you check any updated security viruses, it's easy to find new reflected and stored vulnerabilities discovered monthly, which we're kind of seeing on HackerOne. However, the same is not true for DOM-based cross-site scripting. I'm trying to think if I have discovered this before. I'm not sure if I have, which is getting scarce nowadays. The reason is that DOM-based cross-site scripting is completely browser-based and does not need to go to the server and back to the client. At one point, a POC example of DOM-based cross-site scripting could be created using a static HTML page. However, with the improved inherent security of web browsers, DOM-based cross-site scripting has become extremely difficult. Before we dive into DOM-based, let's review what document object model is. The DOM is a programming interface representing a web document as a tree. The DOM makes it possible to programmatically, I always suck at saying that word, programmatically access and manipulate the different parts of a website using JavaScript. Let's consider a practical example. Consider the HTML code of example.com in the screenshot below, as fetched on the 1st of February 2024. We open the web dev tools using the Firefox web browser and check the inspector tab. Which is, you guys actually saw me do that when I was checking. I should have explained what I was doing, but when my, maybe it's still open. Is it still open? When my cross-site scripting failed, what I was doing here, I right-click and did inspect, and then I did inspect again, because it allows me to see the code on the actual page, and that's why I was like, oh, why did it fail? I was like, oh, frick, I forgot the alert on the script, so it was taking my script and everything properly, but that's what I was doing. Now, this one, if we do inspect, we'll see that it has the alert in there and everything. So that's what I was doing there, was inspecting to see why did this not work, because sometimes it would be like, maybe we realize that we have to do a TD and then, or we have to escape that with one of these keys. You actually saw that in the HackerOne report. You might have to escape something weird before you can do your cross-site scripting. So if it doesn't execute right away, it can be helpful to right-click, inspect, and we can dive into that. All right, the DOM tree shown above is like the following list with sublists, right? We have our document. We have our HTML, right? We have our head, title, meta style. We have our body, and you kind of learn this when you learn basic HTML. You'll learn about setting up some of these pages. It starts with the document node and branches into doc type and HTML. The HTML node branches into head and body. The head is a title, a few meta tags, and a style. In this simple example, the body has a single div that branches into one H1 and 2P. This is a concise page. More practical pages would have tens or hundreds of branches. We can view the DOM tree using the web browser's built-in web developers tools. For example, press Ctrl-Shift-I in Firefox and check the inspector tab. And we kind of saw that on that other page I was looking at. Alternatively, we can access the JavaScript console as mentioned in task 2. Using JavaScript, you can manipulate the DOM tree. For example, you create a new element using document create element, add a child to any element using element append. So like I said, guys, I don't think I've ever found DOM-based cross-site scripting. I've had Burp Suite reported a few times, but it was false positives. So, I mean, helpful to understand this, but probably not going to exploit it in the real world. Maybe you will on some obscure app. I'm not sure. Maybe I just suck at finding it. DOM-based cross-site scripting vulns take place within the browser. They don't need to go to the server and return to the client's web browser. In other words, the attacker will try to exploit the situation by injecting a malicious script, for example, into the URL, and it will be executed on the client side without any role for the server in this. We will present an elementary and minimal static site without relying on the backend code to demonstrate this concept. A vulnerable static site. So consider the following basic example. It is too simple that it's unrealistic. However, it's enough to demonstrate the DOM-based cross-site scripting. All right, vulnerable page, div ID greeting, constant name, new URL search parameter, get name from the window location search, so it's accepting the data there, and then it's writing it out from there. That's kind of our vulnerability. The page above expects the user to provide their name after name in the screenshot below. The user has entered a web tester after name in the URL. The greeting worked as expected and displayed as hello web tester. Finally, the DOM structure on the right is left intact. The DOM has 3 direct children. A user might try to do this, blah, blah. So we could actually like do this, I guess. Open that. Terminal. Do I have anything in here? Make directory for, and we'll just nano. Right? And if we look over at what we're trying to do, it's like looking for a name parameter. And it's doing Tyler. We could do HTML injection first. Right? And we have our HTML injection. And then, of course, we can also do our script. And we have cross-site scripting. And you can see that's kind of what it's showing us right there. This illustrates a couple of things. The server has no direct role in DOM-based vulnerabilities. In this demonstration, everything took place on the client's browser without using a backend, and the DOM was insecurely modified using document.write. Here's our fixed static site. All right, so we can actually do this as well, just for our own learning. Oops. Oh, we could. Let's do there's Tyler. We can try. See that? There's the fix in action. And it's because they're encoding the URI component, right? URL encoding it, so it's not executing JavaScript. One way to fix this page is by avoiding adding user input directly. Instead, we first escape the user input using encode URI component and then add it to text content. The previous attempt does not work now. We can see that the users added JavaScript as part of their input. The JavaScript code is displayed as encoded characters, prevents no threat in the current context. The DOM structure is no longer affected when the user attempts to add code as part of their submitted name. DOM-based cross-site scripting is reflected via the server. Nay. It only happens on the client side. Yay. Which JavaScript method was used to escape the user input? That was our encode URI component. Boom. All right, almost done with the room, y'all. Context and evasion. The injected payload will most likely find its way within one of the following: between HTML tags, within HTML tags, and inside JavaScript. When cross-site scripting happens between HTML tags, the attacker can run script alert document cookie script. However, when the ejection is within an HTML tag, we need to send the HTML tag to give the script a turn to load. This is what I was trying to talk about, guys. When I was saying you might have to add something like close out a tag, this is what I was talking about. We might adapt our payload to this. We actually saw this in that HackerOne report we were looking at, or script alert, blah, blah, or something similar that would fit in the context. I wish I still had the HackerOne report up, but that was one of the HackerOne reports. We might need to terminate the script to run the injected one if we can inject our cross-site scripting with an exacting JavaScript. For instance, we can start the script with that as if we're ending the script and continue from there. If your code is within a JavaScript string, you can close the string with that, complete the command at the semicolon, execute your command, and comment out the rest of the line with that. You could try something like alert document cookie. All right, I know it's confusing, but like, look, guys, if you use Cato, and you use Cato's automate feature, this is like Burp Suite's Intruder, but unlike Burp Suite Community Edition, you're not rate limited. You can, did I send anything to replay? I didn't. Well, with Automate, you could just send a bunch of payloads very quickly through there. You could also use something like FFUF, but if you just use cross-site payloads GitHub, right, we can go to this payload list. And if we were fuzzing a web application that might accept input, we could just fuzz it and then look through the results to see if any of our JavaScript gets executed, right? All right, evasion. Various repos can be compulted to build. Oh, geez, I'm already talking about this. Crazy. This gives you plenty of room for experimentation. One such list is this payload list. Is this literally the one I just pulled up? It freaking is, I think. Amazing. However, sometimes there are filters blocking the payloads. If there's a limitation based on the payload length, then tiny payloads can be a starting point. I've done this before too. I actually had this in the real world, guys. I had a web application that I could tell was vulnerable because I think I was able to do HTML stuff, but I couldn't do any of your typical cross-site scripting because there was a length limit to what I could put in the text box, and I had to use a very, very tiny version of something like this. I don't remember which one it was, and I don't even know if it was one of these. I may have did it a different way. But I had to use a very, very tiny version of code like this, and I was able to get stored cross-site scripting with it. All right, if it's block based on a specific block list, there are various tricks for evasion. We actually saw this in the HackerOne report as well. For instance, a horizontal tab, a new line, or a carriage return can break up the payload. We saw this. I even said, hey, they're escaping. It's looking for JavaScript, and they're breaking it up. So I pointed this out in one of the HackerOne reports we looked at with this exact kind of payload right here. Right? Horizontal tab is 9 in hexadecimal, new line is A, carriage return is D in hexadecimal. So here is the payload, but here's what it looks like. The block list is looking for the word JavaScript. So if you don't say JavaScript, you can kind of bypass it. There are hundreds of evasion techniques. The choice will depend on the target security and require trial and error before achieving a successful outcome. What character does this represent? Which character does this represent? What character does it represent? So this one right here. A horizontal tab is 9 in hexadecimal. New line is A in hexadecimal. And carriage return. So does it just mean tab? Is that what it's looking for? Must be. All right, conclusion. The purpose of this room is to give you a more in-depth understanding of the underlying workings of cross-site scripting scripts. We cover the causes and many remedies for cross-site scripting. Cross-site scripting. That's weird to say. Understanding what is happening behind the scenes should give you an edge in exploring existing exploits and adapting them to your needs. This room used a fictional static site to demonstrate one of the cross-site scripting vulnerabilities. Which type was that? I think. Use a fictional static site to demonstrate. I mean, we used a bunch of different sites, right? Oh, does it mean the DOM-based one? Boom. Yeah, I actually spun it up myself too. So we didn't just read it. We spun up our own static website of it. But congratulations. You have completed the room. Share it with your friends. Guys, you are my only friend, so I am sharing with you. I have completed the first room in our new series going through advanced client-side attacks, learning all about cross-site scripting. I just want to repeat once again, if you want to become a pen tester, you need to understand web tags. You need to specifically understand cross-site scripting. You will be asked about cross-site scripting in your interview. You'll be asked, what are the different types of cross-site scripting? You'll be asked, how do you test for cross-site scripting? How would you suggest a client remediate cross-site scripting? And what code is it done in? Well, JavaScript is client-side. Like, you need to know the answers to those things because you will be asked them in your pen testing interview. But hey guys, hopefully you found this helpful. For all of you watching after the fact, thank you for hanging out with me. I hope you did this alongside of me and didn't just watch me. But even if you just watch me, hopefully you learned something along the way, and I will catch you guys in the next one.